Good afternoon and good morning. Hopefully everyone has had a great day today. Today we're going to be going over a final STAAR prep review. This is questions out of the 25, 24, 23, 22, all the way down to 2018 release test. So the way I recommend to do these problems is number one, look at the problem, pause the video, and then after that you attempt to do the problem. If you understand the problem, you get the correct answer, then I explain the problem to make sure that you got it right. But once again, I recommend to always pause the video and practice before I explain the problem and give you the correct solution. So with that being said, we're going to be going over today 21 through question 40 on our final STAAR prep review. So let's get started. So today we're going to go over question 21. What are the equations and the slope of the line shown on the grid? And once again, we are using our Desmos calculator, and it is a STAAR edition or the Texas version Desmos, because again, we are prepping for our STAAR end of course assessment. If you look at the first one, 21, one thing that we have to remember on this is anytime that we go up the mountain, and I'm going to go ahead and draw it, you're going up the mountain, that's going to be a positive slope. So we're going to say that's a positive slope. Whenever you come down the mountain, going like this is going to be a negative slope. Anytime you go straight, like you're walking across, that is a zero slope. And anytime that you are up and down and you're falling off the mountain, this is called an undefined slope. And when we look at that, we look at, first of all, number one being that zero slope is like you're walking and we say it's zero fun to walk. So if you're going up, the duck always says puff, puff, positive, up the mountain. If you're coming down, you're going to go nice. It's nice to be negative, so we're going to go down, and it's nice to be negative, going easy. Then you're going to go straight down, and it's going to be zero, and then you're going to fall off the cliff, and of course, that's an undefined slope. So if you look at this question, looking at this question right here, you look at this line, and this line is actually an undefined slope. So with this being undefined, anytime that you have a line going up and down, that is considered an undefined slope. So let's take a look at the types of answer choices that we have. So once again, the slope is not negative 1, 6. The slope is not 0. The slope is not 6. The slope is undefined. So if you look at this question, that already we know the answer choice is J. But then again, we want to see the correct answer. Well, let's look at the line. And we're going to see where it crosses the line. It crosses through our x-axis right here. And if you see that right there, it's going to cross the x-axis, and it's at 6. So the answer is x equals to 6. So this line is x equals to 6. Why? Because it crosses our x-axis. And of course, even by knowing that, we would eliminate f. We would eliminate h. So it could be this one or this one going the other route. But again, we know this is not a zero slope. A zero slope is something like this. This would be a zero slope. Anytime you have a vertical line, this is called an undefined slope. So the answer is x equals to 6, and the slope is undefined. The answer choice is J. If we look at question number 22, you might want to pause it, see if you can do that one. This is one of the easiest problems to do on our STAAR end of course assessment. Why? Because we look at the square root of, right here, square root of 96, and that is an easy Desmos input. So once again, all we do is we look at the question, and we're going to go ahead and see our answer choices. And you can try it out. And all you do is input square root of 96. And how do you input square root of 96? You have the square root of 96 right here, square root of 96. The answer is 9.79. And we're looking for it to be equivalent. It's got to be equal. So once again, we know 24 is not equal to 9.79. We know that 48 is not equal to 9.79. So automatically you can scratch those two. Now we have a 50-50 chance to get it right. So on the second one, I would input the second one, which is 8 square roots of 6, and we just input it the way we see it, 8 square roots of 6. And that is 19.59. Once again, that one does not give you 9.79. Most likely it is D. But once again, I want to make sure that it is correct. So I'm going to go ahead and input 4 square roots of 6. I'm going to go ahead and do 4 square roots of 6. And 9.79 is equivalent to 9.79. The answer choice is D. For those of you that know the ladder method, you can also do the ladder method. If let's say you don't have a calculator and you want to use the ladder method to check, you can always put 96 and you say, well, what divides into 96 starting on the second floor? That's going to be 2. That's going to be 4. Carry 1, 6. That's going to be 2 into 16 would be 8. So 96 divided by 2 is, of course, 48. Then I can also divide that by 2. That gives me 24. I'm going to go ahead and divide that by 2 once again. That gives me a 12. And then I'm going to divide it once again by 2. And that gives me a 6. Then I can't divide it by 2, so I'm going to go up the stairs. I'm going to go up to 3, and 3 goes into 3. 3 goes into 6 2 times, so that gives me a 2. And then I'm going to divide 2 into 2, which gives me a 1. So now I have all the way down to the first floor. I'm going to take my groupings. I have a group of 2s. I have another group of 2s, and that's all I have. So I'm going to go ahead and a group of 2. Group of 2 is 4. I'm going to put that on the outside, and I'm going to put the leftover square root on the inside. So I have 2 right here. 2, I multiply, and that gives me 4. And what's left over is this one, 3, 2, and 1. And all I do is multiply. 3 times 2 times 1, and it gives me 6. 4 square roots of 6. And this is a correct way to check it, just in case you want to check it using the ladder method. But once again, why use that if you can go ahead and just use Desmos and let Desmos do the work for us. So let me go ahead and delete the work, so then that way we can look at the next one. And I'm going to go ahead and click on this, cancel. I'm going to go ahead and clear the page, so then that way we can clear the work. And we're going to look at number 23. This one's a good one. And this one is, which value of x makes the equation true? So I'm going to go ahead and input this equation, and I'm going to test out 3.5. And I'm going to test it out in where x is and see if it makes it equal to true. And if it is true, then that is your answer. So all we're going to do is we're going to input it as is, and instead of the x, I'm going to go ahead and test it out with 3.5. So I'm going to go ahead and put 1.25, open parentheses, 4 times the x, and the x is 3.5, and then after that I'm going to subtract 10 to that, close my parentheses, and the answer is 5. That does not give me 7.5, so that is wrong. So then I'm going to test it out for x equals to -1. So instead of putting 3.5, I'm going to go ahead and take that away and put -1. So I go 1.25 times 4 times -1 minus 10 equals to 7.5. No, it does not. It equals to 17.5 negative, and that is wrong. Then I'm going to put in my next one, which is -0.5. I'm going to go ahead and input that, take away the -1, and I'm going to put -0.5. And that gives me -15. That also gives me a false statement. And then, of course, I'm going to go ahead and do the last check, which is 4. Instead of -1.5, I'm going to take away and put it as 4. Then I get 7.5, so the answer choice is D. So that is the answer choice to that problem just by doing a guess and check. Now, if you know how to do distributive property, and I'm going to rewrite the equation for you. 1.25, open parentheses, 4x minus 10, close parentheses, equals 7.5. If you solve this problem, it's also going to give you the same exact answer. So I'm going to use blue so you can see my work. I can use distributive property here and distributive property here. I multiply 1.25 times 4x gives me a 5x. and I'm going to multiply 1.25 times the negative 10, and if you don't know how to do that, you go ahead and input it into Desmos, and the answer is going to be negative 10, and I'm going to add 2.5. So that's going to be a 2.5, I believe. No, let me just put it in Desmos. Let Desmos do the work. Why break my head over it if I can let Desmos do the work? 1.25 times negative 10, and it gives me negative 12.5. Equals to 7.5. Now I'm going to go ahead and do my railroad tracks, and I'm going to circle the 5x. I'm going to get rid of negative 12.5, so I'm going to add 12.5, and then I'm going to add 12.5 to this side. Then I do my line so I don't confuse myself, and then of course I'm going to plus and minus goes away. I have 5x equals to 12.5 plus 7.5, which gives me a total of 20. And then of course I'm going to divide both sides by the number next to the letter. The number next to the letter is 5. 5 divided by 5 is 1, so x equals to 4. And the answer is 4. So not only did I double check it, I triple checked it, and I did it via the method of distributive property, and I also did it the method via Desmos, whichever way works for you, but I would recommend to do the opposite way to check your work on that problem. The next one we're going to deal with is number 24. It says which best represents the domain. So the domain, we got to make sure we understand what domain is. Our domain is our x value. So in blue, I'm going to go ahead and circle my domain. It's all my x values. So if you look at my domain, it's right here, right here, right here, right here, right here. It keeps on going. So look at my domain. The U shape keeps on going, and then the U shape keeps on going. So it's going to be all the numbers going from there to there. It's going to keep on expanding, and then this one is going to keep on expanding all the way. So this would be negative infinity to positive infinity because it goes on forever. So the domain of this quadratic, and it's usually true for all quadratics or most quadratics, that the domain is always going to be all real numbers. Why? Because if you look at all real numbers, it starts right here at the vertex and it keeps on expanding outward towards the positives, and it keeps on expanding outward towards the negatives, and it's every single number. So the answer is which of the best represents the domain of f. The domain of f, which is our quadratic, it's going to be letter G, which is all real numbers. Don't let J fool you because it says all real numbers less than negative 3 and greater than 2. It might try to fool you and give you that answer, but once again, that is not correct. And of course, they try to fool you with F, and they try to fool you with H. But H, remember that domain is not Y. Automatically, you can cross that one out. All real numbers less than negative 3 and greater than 2. Of course, that is false because remember that the graph keeps on expanding both sides via the domain. So the correct answer is G. So you might want to try number 25 and 26 next. And what is the slope of the graph of y equals to 12x minus 19? Go ahead and find the slope. And of course, number 26, which function is equivalent to g of x, x squared plus 15x minus 54. And of course, they give you everything there. And all you do is input that one into Desmos. So you can pause it, try those two problems, and see if you get the right answer. If you look at number 25, 25 does not require Desmos. Why? Because the only thing that we have to know here is that pretty much, let me move this out of the way, y equals to mx plus b. And our m is our slope, and our m is our rate of change. So this is your slope. So this already, they give it to you in y equals mx plus b. So it is y equals to 12x minus 19. So automatically the 12 is the slope. So I can get the answer as it being letter D. Once again, the negative 19 is your y-intercept. So this one would be wrong. They try to trick you with negative 12 19ths and 19 12ths. They just put those two numbers and they put them into a fraction and they box them up for you. But once again, it is already in y equals mx plus b format. If you look at 26, what you would do is you would input this into Desmos and let Desmos do the work for you. So my problem here is to try it out. All I would do is input this right here into Desmos and let Desmos do the work for you. So go ahead and input that one into Desmos and make sure that you get it correctly. So I'm going to go ahead and input it. X squared positive 15x minus 54. And then I'm going to look at my U shape. There it is. I'm going to look at this graph and remember that this graph has to match one of these, either F, G, H, and J. And once again, there's no need to worry about the G of X, so scratch that one out. And there's no need to worry about those G of X's. All you're going to input is the after the equal sign. And you're not even going to put in the equal sign because it might give you an error. So once again, let's input the first one. We're going to go ahead and put X plus 9. Close parentheses, x minus 6. Close parentheses, and automatically you can already see it. I gotta make sure my inputting is correct on both of them because remember I did the last one and I inputted it wrong. So automatically this one is incorrect. But once again, I want to leave it up there. So I'm just going to click on the color and input the next one to see if that one is the correct answer. And remember, in order for them to be equal, they have to be the exact graph. They got to overlap each other. And if they don't overlap each other, then if they look alike, it's fine they look alike. But remember, they're looking for equivalence. So if you take one off and you put it back, it has to be the same graph. So you open parentheses. I'm going to go ahead and do x minus 3. And there it is. I'm going to close my parentheses because I almost forgot. So the way I do this is I'm going to look at the entire graph. I'm going to go ahead and take out the green and the red is there. I'm going to take out that one and there it is. That one is that one. So that is your correct answer. So my correct answer is x plus 18 and let me highlight this. My correct answer is letter G. Now, if I want to solve this, then I would check it via the FOIL method. So then I would open parentheses. All I'm going to do is rewrite this part. And I would use my FOIL method, first, outer, inner, last. So I'm going to underline the x, and I'm going to distribute to the x. And this is like a double distributive, x squared, x times x is x squared. Distribute, and that's going to be negative 3x. I'm done with that, so I'm going to scratch it out. And in green, I'm going to go ahead and do my next distributive. 18 times x is 18 positive 18x. Then I'm going to do 18 times negative 3, and that's going to give me a negative 18, 26, 36, 54. And then, of course, I'm going to go ahead and combine like terms. And the combining like terms, you think of cows and cows together. All you do is input them into Desmos if you want to, and it is x squared positive 15x minus 54. So that you're telling me that is my correct answer. This is my correct answer. This one has to match this, and it does. So that's my triple check right there. And so I know via the FOIL method, if I want to check via the box method also works. The next one we're going to do is a simple exponential function. And why do we know this is an exponential function? And I'm going to write it down. It's an exponential function. And let me erase it because it doesn't look that clear. So let me bring this down. So why do I know it's an exponential function? Because it has, this is exponential because it has this tiny little x. If you look at that and you zoom in, you see that tiny little x? That means it's an exponential function. So that is the reason why it's an exponent. It's not x to the square, because if it would be x to the second power, then that would be a quadratic. This is an exponential function, and they all look the same, but there's one key: the x and y intercepts and the asymptote. So you see the y-intercept right here, you see the y-intercept right there, you see the y-intercept right there, and the y-intercept right here. So if I want to get the easy way, if you have it in this format, this is always the y-intercept. So then that's your initial rate or your y-intercept. And remember that when we put it on Desmos, you don't have to do that. You don't have to put f of x. So I'm going to see which one has a y-intercept of 2. And if you look at this one, it could be this one because it's under 5, and it could be this one, it's under there. And then of course it could be 10. Nope, this is not a y-intercept of 2, and this is a 5, so automatically you have your choices as being 50%. Now the next step I'm going to do is I have my y-intercept, and I got to look at it very closely. Might be 2, so the next step is to graph. So what I'm going to do is I'm going to graph this exponential function into Desmos, and I'm going to let Desmos do the work. So then I'm going to say 2, open parentheses, 5, close parentheses, raised to the x, it's a to the b to the x, and there it is. So let me see if my intercept is correct. My x-intercept is 0, 2, and as you can see, it goes down and it goes to 0, 2. Then if I go right here, I kind of see the 5 there. I kind of see it approaching right here. It's going to approach about right there. It's going to cross about right there, and it's going to keep on expanding. So once again, it could be this one and it could be this one. So I'm going to look at both graphs and I'm going to say, well, which one is it? Because they look kind of the same, but I got to look at the graph and look at the sharp incline here. And you're going to look at another point here. You're going to look at 1, 5. This is another point. So not only did this one test us on our intercepts, it didn't really test us on our intercepts. It tested us on another point. And if we look at this point, and I'm going to put this in orange, this point right here, the x is 1 and the y is 5, approximately. And if I look at this one, the x is 1. This is 1. Let me erase it. The x is 1. And the y is right here, 10. So which one has the graph of 1, 5 or 1, 10? So all I do is click on this graph, and I'm looking for 1, so I can always hold down and slide it all the way up and find out, okay, what's the number of 1 to 10? There it is, 1.1, approximately 1. There it is, 1, 10. The answer choice is F. So this is a tricky one. Why? Because you can't really see your y-intercept. So what do you do when you don't see the y-intercept? You have to find another point, and this is like a drag and drop and trying to graph and trying to find the exact point. So the answer choice is F. If we look at number 28, what is the equation in slope-intercept form of the line that passes through the points -4, 2 and 12, 6? This is a very easy one. Why? Because we're going to input our table into Desmos. Remember, our order pair is very simple. Our order pair is x, y. So we will put in our table. The first one is -4, 2, and the second one is 12, 6. So go ahead and input the table, try to pick the correct one, try to analyze that question and find out what the answer is. Even if you didn't know how to do this, do it without a table and then go ahead and input it. So the first one would be, I would put it into a table format, and the first one under table, I would input -4, 2, and then I would input 12, 6. Next step, after I input, I'm going to add regression, which is a leaf right here, and it's going to pop out the answer y equals to 0.25x, which my rate of change is 0.25, but that's not what they're asking for. They're asking for the slope-intercept form, which is this equation. So I look at that, okay, it could be letter, automatically I get rid of h. If you look at this, I get rid of that one and I get rid of that one. And it's going to be y equals 0.25 plus 3, and the answer is F, just by looking and having Desmos do the work for us. If you look at 29, 29 is another quadratic. We're asking which coordinates best represent the vertex. This one is not really a Desmos, but you technically can use a Desmos on this. But first step, I'm going to go ahead and find my ordered pair. My ordered pair here, my x value, and I'm going to put my vertex. My vertex is x is 1 and y is -2. And that's all they're asking for, my vertex. And this vertex would actually be a minimum because it's at the bottom. And then I want to check it via the Desmos. Okay, the answer is 1, -2. What best represents the vertex? It's not any of these. Now I want to check it. I can go ahead and input into my Desmos and make sure I graphed it correctly. So I'm going to go ahead and open parentheses, 1, comma, -2, close parentheses, and I'm going to look at my graph, and there it is. And I want to double check that that is the right one. I'm going to check with Desmos, and Desmos agrees that that is the correct one, 1, comma, -2. If I didn't get the right one, you can graph every single one of them and check. You can also label it. So again, it will label your 1, comma, -2 to check to see that it is correct. So that is letter J. Another easy one that Desmos does do. And another thing that I showed my students was that you can always convert any type of decimal. You have a 0.5 and you know that's automatically 50%. All you have to do is press this and it turns it into a fraction. 0.5 is 1/2. So you don't even have to memorize our fractions or our decimals. Why? Because Desmos does it for you. So look at 0.25. So I'm going to put my decimal as 0.25. And then I want to get my, right here, click this. And it gives me 1/4, which is 25%. So once again, it also gives me that. Now, I may want to put other things, but those are the only features that are available for our Desmos calculator. Sometimes these will not be allowed. It just depends on what is allowed on Desmos. So this is another easy one. So if you look at the next one is number 30. Number 30, a baker determined that the annual profit in dollars of selling pies is P to the N. What is the annual profit if a baker sells 400 pies? And remember that N is the number of pies sold. So right here, all we have to know is how many pies are sold. And I'm going to write down N equals to 400. This is all I have to do. So if I look at P to the N, I don't have to worry about anything like this. All I have to do is input 400 into the N's and let Desmos do the work for us. So this is our equation for selling our annual profit, and that's going to pop out our answer. So I'm going to go ahead and N is 400 pies. N is the number of pies. Right here it tells us, and I'm going to put it in blue. Right here, N is the number of pies sold. N is, and I'm going to go ahead and get rid of all these. And all I'm going to do is input the N, which is 400, into Desmos. So I'm not going to worry about this. I'm going to put 52 times N, which is 400, minus 0.05. And then I'm going to go right here. I'm going to do 400. I'm going to do times 400 square. So 400 square, that gives you a total of 1,280. So our annual profit is letter G. And of course, since I don't have negatives, I don't have to put parentheses. But if I did have a negative, I would have to put 400 in parentheses everywhere where there is a negative. If we look at 31, go ahead and do that one. Find me the y-intercept of h of x of 29 times 5.2. And automatically I know this is another exponential. Why? Because you can see that that little x means that it's an exponential graph. So all I'm going to do is input this into Desmos, and I'm going to go ahead and input 29, open parentheses, 5.2, close parentheses, gonna a to the b, and I'm gonna put x, and there it is. There's my graph. Desmos did all the work. I'm gonna find my y-intercept. It's somewhere here. Remember, in order for it to be y-intercept, it has to stick. If it doesn't stick, then that's not my y-intercept. So you can just maneuver it around. Guess it isn't. I passed already. So let me see. It could be here. It could be here. Somewhere here. And remember that sometimes Desmos will highlight it for us. Sometimes it won't. Sometimes I have to drag it like this. And then I'm going to go down, and there it is. 0, 29. So my y-intercept right here where it crosses the y-axis is 0, 29. And this is my y-intercept. Or I can just say 29 is my y-intercept. And once again, looking at my trick, if it's in this format, all I have to do is understand that this is my y-intercept. They're asking that 29, and that is also my y-intercept, which is any format to get the answer. Let's go to number 32. They're asking for a graph which line appears to be an x-intercept of -5 and a y-intercept of 3. Go ahead and try that one. See if you can get it. See if you can get the correct one. And let me know what you get. So I'm going to go ahead and erase this on Desmos. And I'm going to go ahead and I don't have to input anything on this one. Why? Because Desmos does all the work for Desmos doesn't do any of the work because they're already graphed. So we're looking for a graph that has an x-intercept, and this can also be called a 0. Don't forget, a 0 can also be an x-intercept. So -5. So I'm going to look for my x-intercept. Is that -5? -5. This is wrong because I'm looking for an x-intercept to be -5. So I'm going to move on to h. Does h give me an x-intercept of -5? No. Then that one is wrong. Then I'm going to move on to g. Does this one give me an x-intercept? So far, yes. So that could be a correct one. And then this one gives me an x-intercept of -5. That is incorrect. So the correct answer is G. Now, I want to check it to be sure that's right. They also tell me that my y-intercept is 3. This one doesn't have a y-intercept of 3. This one doesn't have a y-intercept of 3. This one does have a y-intercept of 3. If you look at this in orange, that's a y-intercept, and that's an x-intercept, or a 0. This one does not have a y-intercept, right there, of 3. So again, the correct answer choice is G. If you look at question number 33, which expression is equivalent? Once again, equivalent means equal. Got to write that down. Equivalent means equal. So, to this. So all you do is input this into Desmos, and then you input every single one of them, and then once you get your answer, then I would recommend for you to check it via the FOIL method. So I would input the first one, the second one, the third one, the fourth one, whichever graph matches. So the baseline is 24x. Let's do it together. 24x squared minus 22x positive 5. And there is my graph. Sometimes I need to enlarge it. I have to look at my x-intercepts. Where are my x-intercepts? Does it have any x-intercepts? It has one. It's got that graph, so I want to look at it a little bit larger. So I'm going to input the second one, and remember they have to overlap each other, and they got to be the same exact one. I'm going to go ahead and input letter A, open parentheses, 12x, positive 5, close parentheses, open parentheses, 2x plus 1. And remember, sometimes I do tend to make mistakes, so I want to leave them here after I check them to see if it's correct. Automatically, we know they look the same. It looks like a duck. It has to quack like a duck. And it's got to be the same exact graph. And they got to be overlapping. And automatically, I know that one is not overlapping. So this one is wrong. I'm going to go ahead and put that in red. This one is wrong. 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 Okay, next I'm going to put the next one. And all I'm going to do is unhighlight this one. And I'm going to put the second one. I'm going to open parentheses. 8x minus 5. Close parentheses. Open parentheses. 3x minus 1. Close parentheses. They kind of look kind of the same, but if you zoom it in, you may say, okay, maybe this one is correct. But remember, if I take this one out and I put it back in, they're not right on top of each other. They got to look exactly the same. So most likely, if I put this one correctly, let me just double check. 8x minus 5, 3x minus 1. This one is also probably going to be wrong. And then let me check that I inputted this one correct. So let's input the next one. So I'm going to unclick this one. And then I'm going to do this one. And again, B was very, very close, but no cookie for that one. So open parentheses, I'm going to do 12x minus 5. Close parentheses, open parentheses, 2x minus 1. Close parentheses. Got to make sure the graph is somewhere there. Looks interesting because let's check it. So I'm going to take it off. It's right on top of it. So let me click it back on. I'm going to take it off right on top of it. So most likely this is the correct one. But I want to do one more check because remember the letter B was kind of similar. So I just want to check the next one. Just make sure that this one is incorrect. I'm going to open parentheses 8x positive 5. Close parentheses, open parentheses, 3x plus 1. Close parentheses, and automatically I know that one is not correct. So the answer choice has to be C. So the way I would check it, and I know this one is wrong already. The correct answer is this. So what I would do is I would check it via the FOIL method to check to make sure that this is correct. So I'm going to rewrite this equation or expression. I'm going to just rewrite it. 12x minus 5, close parentheses, 2x minus 1. And then I'm going to use the distributive property. So I'm going to underline this and I'm going to distribute 12x times 2x gives me 24x squared. I'm going to distribute 12x into the negative 1 and it's going to give me negative 12x. Then I'm done with this. I'm going to scratch it out. I'm going to move on to the next one. Negative 5 times 2x is negative 10x. And then I'm going to go negative 5 times negative 2, which gives me a positive 5. Then I'm going to combine my chickens with my chickens right here. A negative 12x and a negative 10x gives me a negative 22x. So the answer is 24x squared. I'm going to add these two. And that gives me a negative 22x, positive 5. And I'm going to check to make sure that this right here matches our original equation. And it does. So again, I not only double checked it, I triple checked it. And that is the correct answer. The correct answer, and I can guarantee it is letter C. If you look at number 34, a golfer hit a golf ball from the tee box of 6 yards above the ground. The ground shows the height in yards and the golf ball on the ground and on and on. So you're looking at it and it's looking like a quadratic. That actually looks like Top Golf, the way you do the golfing at Top Golf. The question at hand is what is the domain? So once again, you want to try the domain on your own. Automatically, by looking at that, my domain is my x value, and automatically G and H are wrong because that is not my domain. My domain is my x value, so I got to make sure that that gives me the correct answer. So what I'm going to do is I'm going to test each one out. So right here on the x, remember he starts at 0, 6. So my domain starts at 0. This is my x value. And he's going to hit the ball, and it's going to go on, and then it's going to start dropping. And that is an example of a quadratic. And then it's going to start dropping. And this right here is 230. So looking at this, what I look at is, okay, my x value, and I'm going to go ahead and put this in red. My x value is 230. My x value is 0. So my x value goes from 0 all the way to 230. And what is my only choice there in those value ranges? Letter F. So my domain of the function is 0 is less than or equal to x is less than or equal to 230 because it includes a 0 and it includes a 230. So the answer choice is letter F. So we're going to go ahead and look at 35. Number 35, which expression is equivalent? Remember the expression that's equivalent. So right here, I'm just going to add my ducks with my ducks, my cows with my cows, and my chickens with my chickens. So first of all, I'm going to underline the r squares. And I have a negative 6r squared plus a negative r squared, which is a negative 1 squared, which gives me a negative 7r squared. So I want to get rid of these because I already added them. And then I'm going to get my r's together. And my r is 5r and 7r. What is 5r plus 7r? That gives me 12r because I have 7 chickens plus 5 chickens. That gives me a total of 12 chickens. 7 chickens plus 5 chickens is 12 chickens. 5 r's plus 7 r's is 12 r's. Remember, r squares and r's are like chickens and sheep. They are different creatures. Bye. Then the last thing I have is my negative 18. I'm going to put it in black. And I have my positive 10. So I would input that into Desmos, and that would give me a negative 8. Look at the answer choice. G is wrong. J is wrong. The answer choice is letter H. If we look at problem number 36, what they're doing on number 36 is they're saying the graph of f of x is equal to x squared. What's transformed? What does transformed mean? That it's going to be moved. So it's going to be transformed to create the graph g of x. So what are they doing to x? The item, what they're doing to the x is they're getting the function of x squared and they're subtracting 9. So what I'm going to do, and you don't want to pay attention too much with the f of x, you just know that this is 1 and it's going to be transformed into this. So this is like x squared minus 9. So you're getting your f of x, which is your x squared, and you're subtracting 9 to it. So you're looking at x squared minus 9. So you're going to have 2. You're going to go ahead and submit your x squared. So I'm just going to input it, x squared. That's my first graph. And the graph is going to be transformed into f of x. The f of x is x squared minus 9. So I'm going to input the second one, and I'm going to go ahead and put x squared. And what am I doing to x squared? The f of x, I'm subtracting 9 to it. So let's see what happens to it. So if you look at the two graphs, I have my original one, which is a black one. I have my red one. So the question at hand, the graph of G is a reflection of the graph of F. It's not a reflection. Remember, reflection is like you see yourself in the mirror. So it is not a reflection. So this one is wrong. The vertex of the graph of G is 9 units to the right of the vertex of graph of F. So here's my graph of G. The G is the new one. And it's 9 units to the right. So right is this way. Is it 9 units to the right? Nope. The graph of G is a reflection of the graph of F across the y-axis. So I'm going to look at it. not a reflection. If it was a reflection, this is what a reflection would look like. Here is my U shape. This would be a reflection. You look at yourself in the mirror. This is a reflection. The first two are not reflections, so this one is wrong too. The y-intercept of graph of G is 9 units below the y-intercept of F. So here's my y-intercept. It's also my vertex, and they're saying it's 9 units below. That is correct, and the answer choice is D. Okay, we're going to go ahead and move on to question number 37. The table shows a linear relationship. We know it's a linear relationship, so the rate of change. And remember that rate of change, the key word for rate of change is slope. So what am I going to do? All I'm going to do is input this table into Desmos and let Desmos do the work. So let me go ahead and take this out. So the number of years since the trees were planted, this is the x value, and the average height is your y. So all I'm going to do is input this table into Desmos and find out my rate of change. So my Desmos inputting is a table. I'm going to go ahead and input 1, 10, then I'm going to go 3, 24, I'm going to input 6, comma 45. I'm going to go ahead and input 11, comma 80. And I'm going to input 15, comma 108. You're going to add regression, and you're going to get your regression. And right there, just by looking at that equation, you can already tell what the answer is. What is the rate of change? And the rate of change is, of course, the slope. And the slope is the rate of change. It is a number next to the letter. Pick your answer. Make sure it is correct. So what you're going to do is you're going to go ahead and do that one. And you're going to go ahead and find the slope. And the slope is, of course, 7. And, of course, the slope is letter C. And the way I do that is, of course, I look at y equals to 7x plus 3. And this right here is my slope. And that is my rate of change. And that is my slope for 37. If I look at question number 38, they're asking me what is the equivalent expression for a to raised to the p. So once again, they're asking for just the p value. So I would like for you to do that one. Try it out. Let me know how it is and whether you get the correct answer. So let me go ahead and clear the page just to make sure that we get the correct answer. Try it out and let me know what the value of p is. And I'm going to look at that and I'm going to go ahead and say, we're going to go open parentheses. It's going to be x to the 22. And then you're going to do x to the 7 raised to the third. And remember that this is a power raised to a power. So you're going to multiply the powers. So this one you're going to keep it the same, x to the 22nd. And here 7 times 3 is, of course, times x to the 21st. And then I'm going to add the powers. And that's going to keep the same base. And I'm going to add the 21 plus the 22, and that gives me a 43. So that is my answer. So that is my answer choice. The question at hand on this one is that p equals to 43. And that is my only answer choice. Okay, I'm going to go ahead and look at problem number 39. So if I look at problem number 39, let me go ahead and delete all the rest of the problems. So then that way we can have a clean paper. we're saying which expression is equivalent to that all the way to the expression of the final expression. So what I'm going to do is I'm going to dissect this one, because remember that we have to do the big division sign. And remember that 45 divided by 15 is of course going to be 3. And then I'm going to put an m because I have a pair of m's, I have a pair of p's, and I have a pair of v's. So what I'm going to do is I'm going to subtract the exponents. So 45 divided by 15 is 3. That's how I got that one. My m, I'm going to subtract negative 6 divided by, divided by m to the negative 2. So it's negative 6 minus negative 2, and you input that into Desmos. And that gives you negative 6 minus minus 2, which does give me a negative 6 minus minus 2 gives me a negative 4. And then I have the p, I have 2 minus 8, which gives me a negative 6, and I can go ahead and input that into Desmos, and 12 minus minus negative 4 gives me a 12 minus minus negative 4, which gives me a 16. And then of course, remember that you cannot have any negative exponents. So I'm going to keep on going, and I'm going to leave the 3 on the top. On the m, I'm going to throw it to the bottom. It becomes positive. The p, I'm going to throw it to the bottom. It becomes positive. And the v is happy being by himself, and he stays at the top. So that is my answer. Remember, in order to change the negatives, I got to throw them to the bottom in the denominator. Look at the answer choices. Let me know which one it is. And the answer choice is letter B. And what I would recommend on number 39 is for you to attempt to do that one without me doing the work, and then you try to get this correct answer the way we did it. And the last problem that we're going to do is from our part 2. And let me go ahead and get the part 2 problem. So it's only going to be one that we're going to do, which is problem number 40. So it's going to load. And we're looking at problem number 40. And now they're going to give us the exponential function. And now they want us to find which one of these will give you this answer, which is best represented by the graph. So what I would do is I would input every single one of these into Desmos, and I look for some key features. And of course, my y-intercept is 6, so I'm looking for that key feature. And I am going to see some that, of course, has something else as another key feature on this one, like the one we did before. It also has a key feature of 1, 2, because just by looking at our answer choices, I already see that there's one that has the y-intercept, well, at least 2 that have the y-intercept of 6, which is A and B. So what I would recommend is, let me go ahead and do the first one, and I'm going to go ahead and input every single one of them. Do not forget that we don't have to put g of x. All we have to do is put the equation. So I'm going to go ahead and do 6 open parentheses. I'm going to do 1 divided by 3 right here. I'm going to go ahead and put my space, or I can do this arrow here. I'm going to close my parentheses, and I'm going to go a to the b raised to the x, and there's my 1. I'm going to go ahead and put my next one, which is 6 open parentheses 3 close parentheses raised to the x, and that's my second one. And automatically with the second one, it's backwards, so automatically I can get this one out of the way. If you look at my second one, the second graph, it's upside down, so this one is automatically out. So let me go ahead and click on this one as this one being out. So that solves that problem. But I would still leave it there just to double check my work. My third one is 6 minus open parentheses 1 divided by 3 close parentheses. I would do my space here, close, raised to the x, and that one is backwards. That one is also one I'm going to get rid of, and maybe I might be lucky enough to get rid of my third one. So I'm going to look at the next one. And again, I do have another order pair, so then that way, in case you don't get the right answer, that is also going to be fine. You can do that point. So it's going to be 3 open parentheses, raised to the x, right here. And that one is not even correct either because it's not shaped in the graph. So what I'm going to do is I'm going to take a look at this feature, and there's another item that we're looking at here, and we're looking at this as being your y-intercept, but we also have this 1, 2, and I want to make sure that it does have 1, 2, and there it is, 1, 2. So the correct answer choice is letter A. So I hope that has been very beneficial. These are questions number 21 through 40. Hopefully it helped you. What I would recommend is to make sure that you do the problem first and then listen to the answers after. Have a great day, and we will see you soon. Thank you.